Yeah, quickly. Hey. Okay, so for number one, you should have drawn a plane first. Does your plane look like a this? Did you label it plane R? Did you label it plane R? I don't believe you, John. That's actually pretty good, okay? Let's go. Now, the line L, listen, the line L intersects the plane. Does that mean that line L can be inside the plane? No. Watch. So this is our plane R, okay? Your line should have gone through the plane. It should have intersected the plane. Now look, hey, eyes up here. Part of my Apple Pencil is visible to you guys. Do you guys agree? Yeah. And part of it is not visible. Agreed? Yeah. The part that's invisible to you, how do we draw that on our diagram? John? Dotted line. Excellent. Okay. So part of your line should be solid and the other part should be dotted. Do we agree? And for it to be a line, it has to have how many arrows? Dos. But it also said it intersects the plane at what angle? 45 degrees. So you're going to draw an angle mark going down to your plane and label that 45 degrees. I also forgot to label one thing. What did I forget to label? The line. What is the line?
L lowercase.
Lowercase L. Questions?
That's it?
That's it.
Oh, you just had
Okay, number two. Okay, number two, it says AB. But AB is what? A line, array, or a segment? How do you know it's a segment?
Because it has the line, it has no arrow marks.
No arrowheads. So draw a segment with endpoints. What are the two endpoints? A and B. It says it's in what? In plane R. So we're going to draw R around AB. Like this. And we label this plane R. Bisected by a point C. What does that mean?
in the middle of the line.
In the middle.
Line.
You can't be in the middle of a line because the line extends forever. In the middle of the segment. So draw in the middle of the segment, put a point, and put the letter C. With D also on AB. Does it matter where D goes? As long as it's where?
Attached to C.
Attached to C.
It's on the line, but C has its one.
First of all, I don't see a line, John.
Wait, with point D, is it attached to C?
No, it's not attached to C. It doesn't have to
Is it on
be.
the plane?
It's not. It doesn't have to. You can't put D over here.
It's on the segment.
Cody? On the line segment, AB. So you could have had it over here. You could have had it on the left side, but you need to label this D. Make sure your point C is where on the line AB? In the middle. Okay, it needs to bisect it. We Gucci? Questions? All right. How we are starting is I'm going to ask you a very controversial question, and you're probably going to argue with the people next to you, okay? Uh-oh, where'd my question go? If two lines don't intersect, then they are parallel. I would like you in your group of three to discuss this example and tell me whether this is true or false. And if it's false, give me a counter example. Go. Let's discuss. How many groups think that this is a true statement? That if lines don't intersect, then they are parallel? Did anyone think that it was false? Bryson, why did you think it was false? Hold on, listen to Bryson because he's the only one that got it right.
Alright. Oh, let's go. It can have a point at the end.
Yeah.
So So it's not going on forever.
No.
Okay.
It says two what? Lines. Do lines go on forever?
Yes.
Absolutely. Sophia,
Parallel lines are supposed to be across from each other. aren't
what do you mean by that?
Like a line, like facing the same length, they have to be like this.
They have to be facing the same direction. Do you agree? Okay, I agree with that. Okay, take a look at these two red lines on the board. Are they parallel?
No.
Will they intersect?
Yes.
So you agree that you're saying that this is the only line I could draw that will never intersect this one.
Yes.
Is there another line that I could draw that's not parallel that won't intersect that? I disagree. I'm going to give you a line over here.
Maybe on a different plane.
Will this line ever intersect that line over there?
No.
Continue them on forever. Will they ever intersect?
Yes.
Ever intersect?
I mean, no, because that was
No,
that.
they're going to miss each other. Do you guys see that? Now, are they parallel to each other?
No.
Are they parallel?
No.
No. Are they facing the same exact direction?
No.
What if I tilted it like this? Now are they facing the same direction?
Yeah.
What?
I mean, yes, because then they'll intersect
No.
like this.
Okay, so you see how these guys are facing the exact same direction? What? You don't see it?
Oh, I got it.
I just said that.
Okay, did everyone just hear what Cody said?
No.
They're on different planes. So if two lines are on different planes, but they never intersect, we have a new word for those. They are skew. Okay? They are skew lines.
You've never learned about skew before?
I mean, you didn't get the question right.
Parallel lines are coplanar and they'll never intersect. In other words, they're facing the exact same direction. Skew lines are non-coplanar, so they cannot be in the same plane, and they are neither parallel nor intersecting. They're neither parallel nor intersecting. We call planes that do not intersect parallel planes. I'm going to throw another nugget for you guys. Hold on, we'll talk about it in a second. Okay, so based on the diagram that's given, don't read the question that I just asked you guys. Don't read that really quickly, okay? Based on the diagram that's given, could you give me two planes in that cube that will never intersect each other? John?
Plane A, G, F, D. If you
Okay.
draw a diagonal line on that plane,
Okay.
it would never intersect a line that's like going vertical like this on B, A, G, C.
Very good. So these planes, did you guys hear the two planes he said? He said the planes both on the left and the right of the cube. Do you guys agree that they're parallel? Because they're facing the exact same direction. John is correct. Okay, they're never going to intersect each other. Could you give me just give me one more set of parallel planes. Cody?
G, F, E, H.
G, F, E, H. Wait. G, F, E, H. Yes, this front face. And which other plane is parallel to it?
D, C, E, A.
D, C, E, B, A. Yes, that's correct. So what Cody said was the front face and the back face are parallel planes. Do you agree with Cody? Yes. I agree with both of them, okay? Can planes be skew? Remember what skew means. It means that they are on different planes and they never intersect. Think about it, talk about it, go.
No.
5, 4, 3, 2, and 1. Does anyone think that you can have skew planes? Raise your hand. Okay, Cody, I'm going to challenge you. Give me an example of planes that are skew.
I couldn't.
Exactly.
No, you can't give me one?
Well, can you tell me if I'm guessing wrong? If I'm not wrong?
I mean, can you give me an example?
So, skew.
Skew means
Skew planes that can never intersect.
they're never going to intersect,
So,
but they're not parallel.
oh, but they're not parallel.
Because skew means that they're not parallel, right?
Oh, yeah, right. So it would
Correct. The answer to this is no, okay? So, remember, skew means they never intersect, right? So do those planes intersect? Yes. So listen, for planes, in order for them to never intersect, they have to be what? Parallel. They cannot be skew. Does that make sense to everyone? So every single wall that you see ever in this entire world is a plane, agreed? If you extended that wall forever, it will intersect whatever wall, like in this school, if you pick any wall and you extend it forever, it will intersect any other wall that you pick in this school.
So you're saying
Yeah.
that it can't be parallel and it can't be intersecting.
Correct.
How does that work?
It doesn't exist.
Oh.
So the answer is no. Planes cannot be skew. Only lines can be
No, I'm
skew.
not talking about a plane right now. I'm talking about a line. Like, how does that work? Like, that doesn't make sense in my brain.
Okay. So, 2 more postulates, people. We have something called the parallel postulate and the perpendicular postulate. Who's making the Quizlet for this chapter? Kristen? Okay. So the parallel postulate says if there is a line and a point not on the line, then there is exactly one line through the point that's parallel to the given line. Tongue twister. But it's way easier if you just draw a picture. And we're going to draw a picture in a second. The perpendicular postulate says if there is a line and a point not on the line, then there is exactly one line through the point perpendicular to the given line. Next to parallel postulate, I would like you guys to draw this diagram. I would like you to draw a line. And the parallel postulate says that there's also a point that's not on that line. So draw any point that's not on that line. All this postulate is saying is that in order to go through this point and to be parallel to this line, there's only one line that exists. In order to go through this point and be parallel to this line, there's only one line that exists. Visualize it for a second. Don't write it down. Visualize it. Visualize one line that's going through this point that's parallel to this guy. And then draw it. Do you agree that this is the only line that will satisfy those requirements?
No.
You don't think so, Sophia?
Wait, yes.
Then draw it.
No.
Prove me wrong.
I can't be wrong.
Okay, so the requirements, hey, listen up. No, if you challenge this, I want you to come up with a counterexample. If you think that this black line is not the only one that we could draw that goes through the red point and is parallel to the red line, draw a different one. If you draw any other line that goes through this point and is not, what isn't true about the blue line?
They're not parallel.
They're not parallel. What isn't true about this blue line? It doesn't have the red point. So in order for these two requirements to be met, there's exactly one answer. Do you guys see that? There's only one possible black line that we could draw that satisfies both of those. Are we in agreement on this? Does it make a little bit more sense now that I drew the picture? Okay, the second postulate, the perpendicular postulate, it says the same exact thing. So draw another line and put a point somewhere that's not on that line. It says there's how many lines that will go through that point and be perpendicular?
One.
There's one. First of all, guys, what does perpendicular mean?
They intersect.
They intersect, but it's a very specific intersection.
90 degrees.
Not at the middle. 90 degrees. So there's only one angle that we can draw that creates a perpendicular symbol down here. Now, if I change anything about a line that goes through this point, if I change anything, are we perpendicular anymore? No. This angle now that's created is not 90 degrees. Do you guys see how the blue line is the only one that we could draw that would satisfy those two conditions? it works for parallel, and it works for perpendicular. Questions? Cool. Transversals. Okay. A transversal is a line that intersects two or more coplanar lines in different points. In different points. Of the three lines that you see, J, K, and M in the diagram, can anyone tell me which one of those three is my transversal? Read the definition again and tell me which of those three lines is my transversal.
Is it M?
Why?
Because it goes between K and J.
Good. It intersects J and K. So M is my transversal. Now, do you guys agree J and K, are they eventually going to intersect?
Yeah.
Like, they're totally not parallel. Do you guys agree with that? But do we see where they intersect? Do we see where they're going to intersect?
No.
Hayden, you say yes. Where do they intersect?
Like when they are going to?
Yeah. You should be able to see it, right? Because you said you see it.
Yeah.
Yeah. Like you physically see them intersecting.
Like it's on it?
You physically see them intersecting. Okay. So you don't physically see it. Okay. So if you don't physically see it, don't use it as your transversal. We clear? So the only transversal we can use is M. Got it? Okay. The interior angles occur by drawing a box between the two lines that are not your transversal and connecting the box. So draw a red highlighter across the two lines that are not your transversal and connect them. Do you guys see that? The angles inside the box, we call them internal or interior. And the angles on the outside of the box, we call them exterior. So which angles would I consider to be interior angles? There's 4 of them. 3, 4, 5, and 6. So angle 3, angle 4, angle 5, and angle 6. Exterior. What are the exterior angles? Alex? 1, 2, 7, and 8. Angle 1, angle 2, angle 7, and angle 8. You are correct. Do we all see that? Yes? Okay. Right off the bat, before you write anything down, let's draw our box again. Go along both the lines that are not your transversals and create your interior and your exterior angles. So draw that box, then start writing down the definitions. An alternate interior angle are 2 non-adjacent interior angles on opposite sides of the transversal. Alternate exterior angles. 2 exterior angles on opposite sides of the transversal. Okay. So looking at this figure, who thinks they can point out there's 2 pairs of them, the alternate interior angles? So there are 2 non-adjacent interior angles on opposite sides of the transversal. Hayden?
Like 3 and 4?
3 and 4 is close. They're on opposite sides of the transversal, but they're not satisfying one of these requirements. What?
3 and 6.
How are 3 and 6 different than 3 and 4? Because Kristen is correct. They're non-adjacent. What does non-adjacent mean?
Not the same. Like,
No.
they don't eat, the two angles don't make 90 degrees.
No. What does non-adjacent mean? They're not next to each other. Are 3 and 4 right next to each other? So you can't use them. It has to be 3 and 6. Because alternate means go over your transversal. So 3 was to the left of my transversal. 6 is to the right of it. So alternate over your transversal, and they're both interior. So angle 3 and angle 6 are alternate interior. What are the other two alternate interior angles? 4 and 5. Are 5 and 6 alternate interior? Why not? They're adjacent, okay? Two exterior angles on opposite sides of the transversal. They also need to be non-adjacent. What are two angles that are alternate exterior? Hayden? 2 and 7 would be correct. What's another pair of alternate exterior angles? Sophia? 1 and 8 is correct. Questions on alternate interior versus alternate exterior? John?
I have a question on, like, how did you know to draw the box? Like, how do you know it was, like...
Okay, that's a very good question. So your box is created from drawing start from your two lines that aren't your transversal, which would be J and K. Do you agree? Mm-hmm. And then just draw lines down connecting those, okay? So anything between those two lines is interior. Anything outside those two lines is exterior. Okay?
Why can't it be like 3 and 4, 5, 6?
3 and 4 and 5 and 6, they can't be alternate interior because they're adjacent. They need to be non-adjacent. Nope, they can't be right next to each other. Do you see how 3 and 4 are right next to each other? They can't be right next to each other. Good question. Any other questions, guys? Okay. Next two definitions are J and... Yeah, go ahead, Cody. Same side interior or consecutive interior and corresponding. Same side interior, consecutive interior means there are two interior angles on the same side of the transversal. Which two angles are same side interior angles? Anja? 3 and 4 they're on opposite sides of the transversal. Try again.
So 3 and 5.
3 and 5, very good. Same side of the transversal, and they're both interior. So angle 3 and angle 5. What's the other set of same side interior? Marcus? 4 and 6. You okay, Mario? This one trips up a lot of us, so pay close attention. Corresponding angles are two angles in corresponding positions relative to the two lines. That means one of your angles is going to be from this point, and the other angle is going to be from this point. And each of them are going to correspond to the same location. So if it's top left over here, it's going to be top left over here. Top right will be top right. Bottom left will be bottom left. And bottom right will be bottom right. So 1 is top left. Do you guys agree? What is the top left angle from this point? 5. So 1 and 5 are corresponding. Which angle, Alexis, what's that?
Why is it not 1 and 7?
Because 1 and 7 are both exterior. I agree with that. But remember, for corresponding, it's top left to top left. So it has to be like they're facing the same way, right? You have to go top left to top left. Think about it like quadrants, right? This one's the mirror image of this guy. What would be the corresponding angle to angle 2? 6. So angle 2 and angle 6 are corresponding. Hayden? The corresponding angle to 7 would be 3. Very good. So 3 and 7 are corresponding. And the last one. 4 and 8. Bottom right, bottom right.
What does the green say?
Angle 3 and angle 6. German. Yes. Yeah, Mario?
I said 6.
Where?
This is green says 6.
I said green says angle 3 and angle 7. Did I say 6?
Yeah.
I may have, sorry. I meant 7. Okay, parallel here? No. Do transversals have to intersect? All right, some examples. A transversal intersects only parallel lines. True or false? Why, Mario?
I don't know how to explain it. Because the one in the other example, they weren't parallel.
Very good. Guys, look at the previous example. Parallel lines? No. Okay? They can intersect any 2 lines. They don't have to be parallel. Skew lines are not coplanar. This is true. Why? What? Yeah, it's part of the definition. Skew lines must not be coplanar. They can't be on the same plane. C, if 2 lines are coplanar, then they are parallel. It could be true, but is it true for all 2 lines that are coplanar?
No. It's false.
It's false. What, like, if 2 lines are coplanar, meaning they lie on the same plane, do you guys agree that these 2 red lines should then be parallel? Are they parallel? No, so is this statement true? No, it's false. Because you can have 2 planes that are coplanar and be intersecting. They're not parallel. Okay? If 2 lines are parallel, then exactly 1 plane contains them. Is part of the definition for parallel lines that they have to be in the same plane?
No, they don't have to be the same.
Yes, they do.
This is true.
Oh, they do?
They do have to be in the same plane. Do you remember when I put the other line over here
Yeah.
and I turned it so it was parallel? And I said, once I make them parallel, there's a plane that connects them, okay? If 2 lines are parallel, there has to be exactly 1 plane that connects those 2 lines. Example 2. Think of each segment in the figure as part of a line. Which lines or planes appear to fit the description? Give me a line that's parallel to CD and contains point A. Cody? BA. Or AB. Make sure it has a line symbol above it. 2 arrows. Give me a line that's skew to CD and contains point A. John.
Line AG.
Very good. AG is one of them. Does anyone see the second skew line? Mario? Excellent. AH. C. Lines that are perpendicular to CD and contain point A. Ronnie?
I have a question.
Oh, hold on. Yeah.
Wait, why would GH work or not?
Would GH work? It would not work because it's technically parallel to CD. So remember, parallel doesn't mean that they're not skew anymore. So only AG and AH would work. AB also isn't going to intersect CD, but it's parallel as well, right? Cody, what's up?
AE, that can't work because A is...
A and E would work, but there's no line connecting AE in our diagram. We can't use it as a line. Got it? Okay. C, lines that are perpendicular to CD and contains point A. Sophia? Excellent, AD. How'd you know it was perpendicular? It intersects DC, but what's so special about that intersection? There's a 90 degree symbol. Do you guys see it? That means what?
Right angle.
Right angle, that means what? Perpendicular, okay? Perpendicular. Okay, the planes that are parallel to E, F, G, and it contains point A, B, C, very good. The plane A, B, C. You could include D, or you can take out one of the letters and put D. Whatever floats your boat. But make sure A's in there. Yes, wait. All right, example 3. Name the given angles. Which angles are alternate interior angles? Cody? 2 and 7 and 3 and 6. If you're ever confused, guys, draw your box. The 2 lines that are not the transversal and connect them. You only have to pick from 2, 6, 3, and 7. It must be 2 and 7 because they're not next to each other and they go over the transversal. And it must be 6 and 3 because they're not next to each other and they go over the transversal. Which ones are consecutive interior? Reagan, go for it.
I don't know.
You don't know? Try.
2 and 6.
2 and 6? Wrong. German. 2 and 3. And 6 and 7. Corresponding angles. 5 and 7 is one of them. 1 and 3 is another. 8 and 6. And 4 and 2. Alexis? You want to do D? Okay, what are the alternate exterior?
Angle 1 and 8.
Excellent.
And angle 5 and 4.
Perfect. Guys, conceptually, it was a lot. It's not particularly difficult, but I'm not going to lie, there's a lot of definitions here. There's like at least 8 new pieces of information that you guys just learned. 8 new words, 8 new definitions. You've got to start memorizing them starting tonight. So please, when you're doing your homework, try your homework without going back in the notes. And this is the first time we're learning it, so you're going to have to go back. But try to see if you can remember what we just talked about before you go back in the notes. Got it? So try your homework on your own without going back, and then go back if you have to, okay? The last thing I want to show you is you're going to see some stuff that looks like this on your homework.
What is that?
Okay. It has to identify which is your transversal. So like for the first figure, any of those 4 lines could be your transversal, right? Let's say I said to you that this has to be your transversal. What are your interior angles if the blue line is now your transversal? What are your interior angles? 11, 14, 12, and 13 are my interior. Do you guys see that? So if I told you the red line was your transversal, which angles would now be your exterior angles? Cody? 1, 2, 7, and 8. So do you see how it all depends on which line they tell you is the transversal? Watch for that, because they'll have to identify which line is your transversal in your homework, okay? Same thing down here. Any of those 3 could be your transversal. They have to identify which one is your transversal here. Okay.